Dr. Sir. Sir is an accomplished academician, scientist, and administrator with a PhD in pharmaceutical sciences. With over 28 years of experience, he boasts a strong background in research, training, and administration. His expertise spans 3D printing of pharmaceutical products, drug delivery, artificial intelligence, and nanotechnology. Presently, serving as professor and principal at Indira College of Pharmacy, Nanded, Maharashtra. He has a proven track record of mentoring, having guided 15 PhD students and over 19 master's degree projects. His entrepreneurial spirit is evident in founding and leading 3D Fine Inc. Hyderabad, a company dedicated to 3D printing research and development. His commitment to knowledge sharing is reflected in his over 150 research articles and 12 Indian patents. His academic journey includes collaborations with prestigious institutions like IIT Bombay, IIT Kharagpur, and international organizations such as Pearl Packaging AG, Switzerland. Beyond research, he has actively contributed to the field through certifications, professional affiliations, and software proficiencies. His ability to balance academic leadership, research innovation, and administrative responsibilities is commendable. His dedication to advancing pharmaceutical sciences is evident throughout his impressive career. To delve into the intricacies of 3D printing, we are privileged to invite Dr. Sir to begin the technical session.
Thank you. Respected principal sir, and coordinators, and my dear students. We have 3 questions before we start. The first question is, why you are here today? The second question is, why I am here? And third question is, why now? Why not after 1 year? The 3 questions to be answered. You can answer the first question, I believe. Can you answer? Why are you here? One person. Still confusing? Are you not confident that why are you here? You paid some subscription to attend this, right? That you remember very well, but you don't know why are you here. Well, as per IIC, Institutional Innovation Council, you may be here to learn something new away from the subject, routine subject, right? Am I correct? Yes. That's great. Coming to the second point, why I am here? There is a reason. I am here to give you an idea about So I am here to give you an idea about the upcoming technology in the field of pharmaceutical sciences and biomedical sciences. That is 3D printing technology. Well, that is great. It's okay. It's okay, someone will learn 3D printing technology. But why now? Why we should take this lecture now? That's because you know that today is the rat race for any professional. That means when you complete your BCom degree or whatever, then you go for a job. There is a lot of competition. Competition is there or not? Just tell me yes or no. There is not normal, very huge competition. And people are trying to learn new things like coding. Some people learn coding and some certificate courses and so on, right? And similarly, this is one of the techniques which is still unexplored in India. It is already explored a lot in other domains, other countries like USA and UK, Switzerland and Japan and Israel. So always technology is in the forefront. Okay, software I agree, but software will change instantaneous and momentary, and the job in the software is not permanent, right? But whereas the core subjects like pharmacy and any technological subjects like 3D printing will have a lot of scope in your career. Excuse me, my laptop, please. Laptop ఇక్కడ ఉంది. That's great. So, for attending today's whatever seminars by Dr. Sriram and myself, you must have a purpose. You must have a purpose why you have attended. After completing this particular day, you must ignite your thoughts to explore these knowledges in the future and upgrade yourself, and which will help you in the building your career. Agree with me or not? Now, how many of you know the word 3D printing? Just raise your hands. Based on that, I will continue my talk. How many of you? Straight, more straight. 5, 6, 7, 10, around 15, right? Well, all of you know about marble printing, paper printing? Just raise your hands. Still someone don't know what is paper printing? Right. So paper printing is a two-dimensional printing. That means the printer will print on paper, whether it is a color or black and white, in x-axis and y-axis, right? X-axis and y-axis. It's not little mass. Don't worry. Whereas 3D printing, when you talk about 3D printing, you just think like this. It will print in the z-axis or z-axis. Okay, up or down. You can print downwards, you can print upwards. Both sides you can print. So, it will print the material. Usually in 2D printing we use ink liquid, right? Same similar kind of thing is used also in 3D printing. So, but it will be layer by layer. It may be thick, or a little thicker, or it may be a powder. Okay? So, powder layer by layer you will print to make a 3D object. Understood? Now the question is, why? Why do we need 3D printing? We have a lot of technologies. For example, you take aerospace industry, across mechanical engineering, civil engineering, or architecture, electronics, and of course pharmacy. I will give you an example of why we need 3D printing in automobile industry. Everyone knows automobiles, right? Cars and all, bikes and cars. So I just want to give you the basic subject of automobile. Assume that we want to prepare a very lightweight seat. You know, seat. Airplane, for example. Airplane seat, I mean, what you are sitting. Airplane seat, where we sit. So we want to design a lightweight. For example, now the airplane seat will be around 20 kilogram. I want to make a 5 kilogram or less than 5 kilogram chair, metal chair, which is impossible to make using conventional techniques. Whereas using 3D printing technology, it is well possible. Assume that there is a ball, a spherical ball, there is a spherical ball, or mitochondria. Well, very good. You magnify to the ball size, you magnify it to the ball size. Now I ask you to make mitochondria shape without making any hole inside the ball. Is it possible? Mitochondria has some shape inside, right? Like this, spiral shape, snake-like shape, right? Is it possible without opening the ball? Mitochondria, whatever, it has a shape like this, cylinder kind, curved cylinder. You can't open it to make inside. But it is well possible using 3D printing technology. Because in 3D printing, it prints layer by layer by layer. So it simultaneously prints outer layer, also inner parts, outer parts as well as inner parts simultaneously. Now I will show you a small video. You know what is this, right? Do you know? I don't know. What is this? I hope everyone knows it. But here, there are 4 packages. Say 4 colors. Okay? 4 5 colors. Actually, the one you saw in the beginning is a normal printer, but now what you are watching is a bio printer which will print an organ. So the 4 cartridges contain different things. One contains live cells, another contains scaffold materials, some different materials. So you making use of 4 materials is making an object, like an organ. So the hypothetical. But recently, scientists have successfully developed the cartilage, cartilage. So here they are trying to print heart, I think. So you can observe that it is printing layer by layer, it is also printing inside parts simultaneously. Layer by layer. Try to understand this word. Layer by layer it prints. The material is deposited layer by layer. So like this, the cells are placed one upon the other, printed one upon the other, and after curing, it will form a blood vessel. Okay? can print skin upon some damaged leg or something like. Suppose burns. In the burns, you lose the skin, right? Skin material. So you can print skin cells on the leg itself. That means portable printer. This is a portable printer. You can keep the printer on the leg. So it is printing the live cells. Also, you can print inside. Inside, like for example, some liver is damaged. You want to rectify it. You can do print materials inside cells. So here. Now let us directly down into our pharmacy profession. How 3D printing will change our lives in the future? So by increasing or decreasing the size, we can change the dose. Okay? Just observe. The tablets that are printed using 3D printing is called printlets. Printlets, tablets, printlets. So here we use a classical example of you don't need to break the tablet. Okay? You don't need to take 3-4 tablets. You can make polypill. You can make amazing, tasty pills. Orange flavor, chocolate flavor. A boy, for example, he is suffering from chronic disease. He is taking tablet every day, but he doesn't like to because because of bitter taste or whatever. He doesn't like to take tablets. So what we do is, for 7 days, we make 7 flavors containing same drug, same dose. So the boy has chosen the shade. He wanted the particular shade and flavor. And finally ended up with an octopus shaped candy which contains the drug. So what happens here? Similar the case with elderly patients. Elderly patients also, they forget to take properly 3-4 medications. So you can put all 3-4 medications into single formulation and give it to the patient. So it is something like you can imagine a kind of personalized medication or a tailor-made medication. So the drugs you wear are ready-made, I believe, the shirts, but you can tailor make it, right? Yes, it is a bit expensive, but we cannot give a cost for our problems, health problems, right? We don't care about money. If you find any health problem, will you go to Yashoda or a government hospital? Yeah, it's a psychological feeling. It's a psychological feeling because when it comes to health, we do not compromise. Understood? So now, just imagine that in the future, after 5 years, every hospital or the pharmacists of every hospital or the pharmacists in the society, in the roadside pharmacists, you will find a special dispensing room, compounding room. We call it as compounding room that contains a printer like this, the one you are seeing in front of you, and doctor will prescribe the medication as per the body weight, okay, and the pathophysiological conditions. For example, cancer patient. What are the adverse effects of cancer patients? Hair loss and become very thin, bone loss, so many issues are there. So the cancer patients are dose sensitive. A little bit increase or decrease the it will change the physiology of the body. Cancer patient. So how to prevent it? By giving exact dose. But the fixed dose combinations are the fixed doses that are available in the market are say 200 mg, 500 mg, 700 mg like that. If a patient wants 223 milligram tablet dose, you can't get it, you can't break it. So the best option is 3D printing. Well, you can also make in the age-old pharmacies they make some pills kind of thing, but it is only limited to pills. But here, using this machine, you can not only adjust the dose, but also you can modify the shape of the tablet, flavor of the tablet, and dosage form itself. You can make microcapsules, you can make oral dispersible patches, you can make tablets, you can make candies, jellies, gummies, etc. using 3D printing technology, which is very versatile. That's why 3D printing came into the existence. Okay? So I was giving one example that why there is a need of 3D printing in general. Because the first point is, as I told you, in the airplane seat making, okay, you need a 3D printer. Why? Because the shape inside the rod, steel rod, inside, it looks like a feather, feather if you take a cross section, it is not solid. Inside some air spaces are there with some shape. So that space can be created only using 3D printing technology. So 3D printing technology is basically used for rapid prototyping. That means suppose I want to make a design some shape of a car. You need not go to the foundry and make a steel or whatever. You need not make an entire car. You can just use a 3D printing machine and you can print the parts. If you feel okay, then you can go for manufacturing. So it is called prototyping. What is prototyping? Prototyping is a working model. First working model is called prototyping. Okay? So 3D printing is used for prototyping. Also it is used for rapid manufacturing. I'll give a very interesting example. In the aerospace, nowadays they are taking 3D printers. For example, in 2003, Kalpana Chawla has died because of accident, that was a crash, spacecraft crash. How many of you know this news? Oh, great, you are good. So, what happened is, while re-entry in the atmosphere, okay, there is a lot of heat is generated. Around 4000 degrees centigrade heat is generated. To prevent that heat transfer, they use ceramic tiles on the ship, okay, aeroplane. Spaceship, for example. Okay? So what happened? One of the ceramic plate has dislocated. It lost in the space. Good pain. Good pain, it is exposed to the heat, and that caused them to die. There was no alternative that time. After ceramic tile in the pipe chance there. Assume today, same problem came. For example, what they will do? They will take ceramic powder, they will take all powders, titanium, ceramic, metal, whatever, medicines, all medicine raw materials they will take to the space, and in the space they have a printer, different printers are available, and there is one called metal printer or ceramic printer. What it will do? It will print exactly the shape what you want, and that shape they will print immediately. They will attach to the, fix it to the outside. Similarly, they lost some tools. They don't have some nuts and bolts. Wear and tear during transport. Even in our car, if you travel from here to there, something is lost. We don't know. So to fix that, you should go to a shop and buy that nut and bolt, right? But where is the shops in aerospace? You cannot carry all the space, right? Can you carry all the space in your car? So that it will be lost, that will be lost like that. So that's impossible. So using 3D printing technology it is very much possible and it is already in practice. They are doing practice. Coming to pharmaceutical sciences, what they do is they take raw materials, basic materials like basic chemicals like benzene, acetone. Then they will do synthesis, on the spot synthesis, rapid synthesis. Thereafter, they will convert into a drug formulation using 3D printing machine. And any kind, they take only limited kind of medications, raw materials. No need to take 10 strips of everything. Okay? Suppose you are taking 10 strips of ibuprofen, 10 strips of erythromycin, for example. Erythromycin is unutilized because you never got any throat infection, but you got fever and it has got exhausted in 1 month. Ibuprofen. Suppose you want another ibuprofen, where will you go? That's a problem. Can be solved by 3D printing technology. Now we'll have a break up.